Welcome to using the first derivative test. So recall, we have our rule that if f prime goes from positive to negative, then we have a relative max. If we had f prime went from negative to positive, then we had a relative min. And then otherwise, if it doesn't switch signs, then there's no relative extrema. So we are going to go ahead and use the first derivative test to find the relative extrema of the cubic function f of x equals negative x cubed plus 3x squared plus 24x minus 6. So the very first thing we need to do is find the critical values. Again, these are the only places where the relative extrema might occur. So we have f prime of x is equal to, power rule says that would be negative 3x squared plus 6x plus 24. And we are looking for where this is equal to 0 or undefined. Again, we're working with a polynomial. So in this case, this is a never undefined. Again, since we are working with a polynomial. And then on the left, we could go ahead and factor out a negative 3. So we have x squared minus 2x minus 8 left inside. And then that we can go ahead and factor as we have our negative 3 times, if we do an x minus 4, and then x plus 2, that will multiply back to x squared minus 2x minus 8. So we have either x minus 4 equals 0 or x plus 2 equals 0. And we therefore get x equals 4 or negative 2 for our critical values. From here, we're going to go ahead and draw our number line. Note, I'm doing essentially exactly the same thing that I did when I was finding the increasing and decreasing intervals. So if we draw our number line, the points of interest are at negative 2 and 4 for x. F prime is equal to 0 at both of those places. Off to the side, I'm just going to do a quick reminder that f prime of x is equal to negative 3 times x plus 2 times x minus 4. I'm just rearranging the terms so that the ones that correspond to negative 2 is first. If I do my test points, if I pick something over here, so say x equals negative 3, well, that negative, if I plug in f prime of negative 3 to f prime, negative 3 is going to be negative. And then negative 3 plus 2 is negative. And negative 3 minus 4 is negative. And so we get a negative result. If I pick, say, x equals 0 in between negative 2 and 4, f prime of 0 will have a negative for the negative 3 And then 0 plus 2 is now positive, but 0 minus 4 is still negative. And so we now have a positive outcome. And then if we pick x equals, say, 5, and do f prime of 5, we'll have our negative 3 times 5 plus 2 is positive, and 5 minus 4 is positive, and so that will all multiply to give us a negative. So again, I don't care about the actual value. You are welcome to find the explicit value. So if we used the original form of f prime, negative 3x squared plus 6x plus 24, you could plug in negative 3 and get the specific value. Or you can just plug into each of the factors of f prime and figure out the sign, which is what I was doing here. So again, negative 3 is always negative, and then I was figuring out the signs for the remaining two parts. At this point, we can figure out what is happening with f. So a negative derivative, we're going down, flatten out at 0. Positive, we're going back up, flatten out with a 0, and then we're going back down. So we already can see what the graph is looking like here, right? We dip down, turn around, go up, turn around. So if we draw what f would look like, not caring about the actual values, but just graphing what f would look like. We know that it dips down till negative 2, goes back up to 4, and then goes back down. So we have a relative minimum at x equals negative 2 and a relative maximum at x equals 4. So we have a relative min at x equals negative 2. The value would be f of negative 2. And we have a relative max at x equals 4. And again, the value would be whatever f of 4 is. All right. So when I use the first derivative test, I'm not really thinking of it as a test and thinking of the rules. I'm just looking at kind of what my number line picture shows me. All right, let's go ahead and do one more problem. So we are going to use the first derivative test to find the relative extrema of g of x equals 3/2 x to the 4/3 plus 3x minus 3x to the 2/3 plus 1. So just a note here that this function is continuous. We are taking cube roots, which we can do no matter what, is on the inside, but also since the numerator is an even power, it's going to be positive anyways. So what we need to start off with is we need to find the critical values. So we will find g prime of x. So if we do the power rule, 3/2 times 4/3 is 2. And then we'd have x to the 1/3. 4/3 minus 1 is 1/3. Then we would have plus 3. Then we would have minus 3 times 2/3 is 2. And we would have x to the negative 1/3. 2/3 minus 1 is negative 1/3. Our job is to figure out where this is 0 or undefined. So the only place that can cause concern is if the denominator equals 0. So it's going to be undefined at x equals 0. And that's coming from the x to the negative 1/3. That would be 1 over the cubed root of x. And we can't have a 0 in the denominator. Where it is equal to 0, we're going to do a little bit of manipulation here. I'm going to go ahead and pull out my lowest power on the x. So we're going to factor out an x to the negative 1/3. So take out x to the negative 1/3 and factor out. So we'll have x to the negative 1/3 times, this will just add our x to the 1/3, or add a 1/3 to all these powers. So this will become 2x to the 2/3 plus 3x to the 1/3 minus 2. And that's all equal to 0. And then what we are going to do is we are going to, the first part cannot equal 0. So we are going to look at specifically just the second factor. So 2x to the 2/3 plus 3x to the 1/3 minus 2 equals 0. And now I'm going to help myself. I'm going to use a little substitution. So I'm going to set u equal to x to the 1/3. Then what we get is that u squared would be x to the 2/3. And so we are really looking at 2u squared plus 3u minus 2 is equal to 0. This winds up factoring as we'll have a 2u and a u. And then if we do a plus 2 in the second factor and a minus 1 in the first factor, that will give a plus 4u minus u, which is that 3u we're aiming for. So we have 2u minus 1 equals 0, or u plus 2 equals 0. And we get that u is equal to 1/2 or negative 2. And then we'll go back to where we were. So keep in mind that u equals x to the 1/3. So we have 1/2 equals x to the 1/3. To undo doing to the 1/3, we can go ahead and cube both sides. And we get that x is equal to 1/8. Or the other one, we have negative 2 is equal to x to the 1/3. Again, we can undo taking the cube root or raising to the 1/3 power by cubing. And this one gives us x equals negative 8. So we now have our critical values. Where x equals negative 8. We had 0 was where the derivative was undefined, and 1/8. And now we'll go ahead and form our number line. So our points of interest are negative 8, 0, and 1/8. Again, no, I am not spacing these correctly. I have almost as much space between 0 and 1/8 as I had between negative 8 and 0. The main thing is just that these are in order. So here is our x, f prime. We know at negative 8 and 1/8, the derivative was 0. And at 0, the derivative was undefined. Oh, this is not f, this is the function g prime. Then we'll have our test points. So we could use, say, x equals -9, x equals -1, and x equals something tiny. I don't know. Let's do something 1/16, and then maybe use x equals 1 over here. So keep in mind that our derivative, g prime of x, was in factored form. We could do, or we could do the original one. Let's do factored form. So we have x to the -1/3 times, and then we're just going to replace the u's with x to the 1/3. So we have 2x to the 1/3 minus 1 times x to the 1/3 plus 2. So if I do my checkpoints, at -9, we'll have g prime of -9. Raising to the -1/3, we'll have a negative. Then 2 times that raised to the -1/3 minus 1 will still be negative. And then doing that to the 1/3 power plus 2, we will still be negative. It's at -8 where that will switch. So we have a negative here. For this one, g prime of -1, again, raising that to the -1/3 power, we'll still have a negative. And then doing 2 times -1 to the 1/3 power and then subtracting, we will still have a negative. And then raising to the 1/3 power, we just have -1, adding 2, we wind up with positive. So this is positive. Again, when we pass through -8, this root corresponds to that x equals -8. So that's the one that's going to swap signs at -8. So we do have positive for our derivative here. At x equals 1/6, or sorry, 1/16, we take the derivative of that, or evaluated at 1/16. That first piece is now going to be positive. We're taking the cubed root of a positive number. The second piece is still going to be negative. This one corresponds to x equaling 1/8. So we're not going to switch to positive until we pass through 1/8. And then the last one will be positive. And so this is negative. And then for x equaling 1, g prime of 1, taking that cube root, we have a positive. The next term has now switched to positive, and the last term will still be positive. So we wind up with a positive again. Now, if we do what g looks like, we start off going down with a negative derivative. We flatten out, then we go up. Then the derivative's undefined. Sorry, it's taking a moment to catch up. And then we go back down. We flatten out, and then we go back up. So our function was continuous, but the derivative was undefined at that point. We're going to wind up with a cusp. Okay. So if we draw our picture, we have -8, 0, 1/8. Again, my spacing is not completely accurate. Then my graph of G, we start off going down. At 8, we turn around. And then we have a cusp at 0. We go down again, and at 1/8, we turn around and go back up. So we will have relative minima at -8 and 1/8, and a relative maxima at 0. So we're essentially just looking at sort of the relationship between this increasing, decreasing, visualizing again what that would look like for the graph. So this is the first derivative test more as a visual situation as opposed to just reading through the theorem itself.